am obsessed with .NET, AI, and WebAssembly right now. I've been programming for 41 years, and the pinnacle of my work has been building Iron Suite, which I started. Iron PDF, Iron OCR, Iron Barcode, Iron Software's product offering were built with these hands. .NET as a language is beautiful. As an ecosystem, it's beautiful. It is open source. It is stable. It deploys everywhere. Why do I care about WebAssembly? .NET is a runtime environment. That means it almost compiles to native code, but it doesn't. It compiles to this thing called bytecode. And that means that wherever .NET is installed, you can run it, whether it's a laptop, a server, a small AOT device, a mobile phone, whatever. Now, WebAssembly is really interesting because it's also a bytecode runtime. And in .NET 10, C# and .NET compile to WebAssembly, and WebAssembly is everywhere. It's in places, it's propagated everywhere silently, but it's just, it doesn't need to be installed. It's in everyone's computer already. It's already in your web browser. It means .NET can be used inside your web browser, right there inside your web browser, inside your web page, just like Flash used to be, just like Java applets used to be, but more compatible. And that means the future of the internet may be that the interactive sections can be written in real code, verifiable languages, not with JavaScript dingle-dongles, and the rest of the HTML can be kept nice and clean, readable, and about documents, finally. Why do I care about AI? Because if you're not using it, you're lunch. AI is the future of of all software development. It never replaces the engineer. It is, to use the analogy, it's like we used to develop with a pencil. And finally, we got a typewriter. That's like an IDE. AI is the extension of your IDE. It doesn't replace you. It doesn't think for you. What it does is it acts like a mega typewriter. It allows you to extend your capacity as an engineer. It means that it changes AI. How does AI change a software development team? It changes everything, because what you really need is people who know how to use AI and understand how to solve problems, and everybody else can go. We need problem solvers who understand how GPT transformers work, like how to talk to an AI. Yeah, and most of that, don't be shy. That's what we need. A small team of smart people can achieve an awful lot more. Used correctly, it can augment a developer in the most incredible ways. So I came up, it needs to touch the file system, you need threads that plan, and you need worker threads. But all of it requires a software architect sitting there, watching it, going, hey, this is where I want you to go. This is what I want you to do. It doesn't build it for you just randomly. You need to know exactly what you want, exactly how to do it, and monitor it. It's a tool. It's not a replacement for a human being. It's an extension of a human being. Just as a computer and a cell phone are extensions of you, AI becomes an extension of you. What makes modern software ecosystems messy? Let's start with web applications. Oh my God, HTML, CSS, and JavaScript have become a cluster. PDF file format have been clustered. But we've got code here, we've got code there, we've got code there, we've got legacy systems here, we don't want to break anything, we've got a database. There's code everywhere. Some of it maintained, some of it not, maintained by different teams. They don't always understand what's going on, and then you've got code written in multiple languages, and those languages can't talk with one another. That is the state of where most enterprise software is at. It's basically a house of cards. Stability. If I build a software library and I have a common core using WebAssembly, for example, or .NET, I can ensure that that common core is stable. Using AI and test runners and CI/CD, I can create more and more and more and more and more unit tests and integration tests. I mean, code coverage used to be pretty scatty and pretty much anything other than open source projects, with lots of junior developers trying to get their foot in the door by writing one unit test. Of AI get you to 80% code coverage in a few hours. So it makes transpiling to different languages, like if we have code in .NET, I need it in Rust. Well, I can transpile that by test-driven design. I make sure I analyze the .NET. I make sure that it is well covered. The test coverage is good. I add synthetic testing to improve any gaps in the test. And then I transpile the tests first. And I've got a bunch of red tests. And you know what? Red test to green test is a pretty easy problem to solve in AI, because it's got a feedback loop. What AI needs is feedback, constant feedback, because it hallucinates. So it runs a test, it gets a red test. That's a fact. It can now fix it. And it keeps going until they're all green. That is the transpilation pattern that works. Why is WebAssembly in .NET 10 so important? And up to now, you've needed to install the .NET runtime to run it. It outputs to WebAssembly. Two major upgrades. One is that it already runs everywhere. It runs on pretty much every device on the planet and inside your web browser automatically. Wow. Number two, execution speed. We are now in the same ballpark as Rust and C++, but our binaries don't just work on, well, one's compiled for Linux and one's compiled for Mac and one's compiled for Windows and one's for 64, one's for ARM and one's for Ubuntu 16 and one's for Ubuntu 18. That compatibility problem with native binaries, done. We're not doing that anymore. So it allows C# to be more mature than C++ for the first time. It is part of the future of software. Honestly, I'm so excited about the WebAssembly, I don't care too much about any of the other updates. What I do care about is the .NET Foundation, and Microsoft keeps supporting their language. It's not like one of those things like Java's kind of like gone and gone now. No, .NET's on the up and up. Yeah, Microsoft are backing it. Really, the big changes here are in AI and Azure. .NET 10, C#14, biggest improvements are actually in its capacity for a machine to understand and code it, because they know AI is becoming part of everything, and AI is already part of Copilot, it's already part of the Visual Studio, but I expect that it will be integrated with more and more sophisticated AI models for different tasks, like planning projects, executing projects, and the place that I love AI the most is DevOps, because DevOps is a fuzzy problem which you always try to fix with hard logic with no human oversight. Scrap that, get an AI in DevOps chain, make sure it tests things. If tests fail, don't just go, the tests fail, fix them. That is the future of software development, and it allows a small team of very smart people to achieve much more than a big team ever could. The communication is like every developer has 10 junior developers and one pair programmer right beside them. That's how it augments them. It makes a team of 10 produce an output 100. What we're doing is using .NET to produce software that runs in every programming language and works on every device. We are building in C. We do have source code in C. We can transpile that to WebAssembly. We do have code in Rust. We can compile that to WebAssembly. And thanks to .NET 10, we can use C# to make WebAssembly and reuse the code we already have. And it all fits together beautifully. It was the missing part of the puzzle. And .NET 10 has just saved us hundreds of thousands of dollars in development time and cost. How do you keep that all consistent across all these languages? And the truth is, contracts are beautiful. The TSP contracts are my favorite. They're commonly used, designed by Microsoft using TypeScript, which is one of my favorite languages in the first place. I love type JavaScript. Anyway, you've got TSP contracts, And a contract to a developer defines what goes in and out and makes sure that your front end and your back end and your middleware all talk to one another beautifully, allows for boilerplating, allows for tracking, and allows for metrics. Everything just works beautifully as soon as you start working in contracts. Here's the beautiful thing about contracts. For a business person, I am a business person, every contract is a feature. And it means that software architecture becomes about real world features first, not software. And that is why I love TSP contracts. And I don't just use them. I used to use Protobuf. I now use TSP. I don't just use it for server client models. Now I'm using it to define software architecture, because I think that model of using contracts to define software is how to get a good result, allowing back-end developers and front-end developers to work independently, and allowing machines to be involved in boilerplating and testing. How has AI changed the way our developers work and stabilize software? It's only changed a couple of us. Now, most of us are using AI as a replacement for Stack Overflow, let's be realistic. But one or two of us have got the big picture. Here's how you really do it. Here's how you really use AI to develop software. The first thing you do is you realize you need AI on your file system. Google Gravity, Anthropic have Claude Code, OpenAI have Codex. You use all of them. You need planners and analyzer threads, and you need worker threads, and you feed one into the other. I personally find that OpenAI's API is very good, which you can build through Microsoft Azure, which is beautiful for any startups who could apply for BizSpark and get free credit. OpenAI's ChatGPT is very good at analyzing a repository and understanding its weaknesses. Claude Code by Anthropic is a very good set of hands and is not sandboxed. They've really taken it out of the sandbox so it can do stuff. It can implement the plan and say what it's done. But you know what? It doesn't always do what it's told. So you can go back to OpenAI and make sure the plan's done. But planning the next steps, you need a second, third set of eyes. You bring in Gemini Pro 3 using, I like to use Gemini Pro from their new anti-gravity IDE and have that analyze what to do next, export an analysis what these two AIs have done, clean up my PR, send it out, run my DevOps. And that's where we get into the next stop. How does AI turn one developer into a small team? It's a mega typewriter. We've just used 3 AIs to check one another, to fill out a developer's dream. And let's be very clear, the developer isn't hands-off here. They are monitoring each AI and giving it real-time instructions, and it's been instructed to ask questions. In the planning phase, in the review phase, and as it actually runs, we go, hang on, what are you doing? I mean, you have to be the senior programmer here. You got a team of junior programmers, it's just that a sprint takes 30 minutes rather than a week. So you have to be on your toes. This is your work, not the machine's work. What's really beautiful about it? Let's talk about DevOps and AI. AI's most useful task is in its diligence. It may hallucinate, yeah, sure. But you know what else it can do? It can make you 800 unit tests in 20 minutes. It can get you to a 90% code coverage in a few hours. And then talk about diligence. It will run the tests. Look which tests are broken on which platform, testing across multiple platforms using Docker images. Fix every single test and then make a PR. And then in DevOps, we don't just have fixed logic. We have an AI in there that can report the bugs in the DevOps, fix them, and then send it on a loop. No more DevOps headaches, with people with their hands there going, I don't know what's going on. It's just broken in the cloud. How about having it assisted by a machine that can analyze what's happening and report back to home base what to fix? The big wins for AI and development: TDD, unit testing, good documentation, stabilization, ruggedized libraries that are well documented, all the stuff that programmers kind of skip because they're busy, done. Peer review, ensuring that people aren't cutting corners. AIs are really good at making sure that people don't cut corners. And productivity is kind of like going from scratching on a cave wall to a pencil to a typewriter to a computer to what we have now, which is a computer with a natural language augmentation for the user. Just like a telephone. Think about a telephone. What is it? What is a mobile phone? You know what it is? We invented telepathy. What is AI? We just invented everybody gets an IQ of 150. That's what we invented. But you need to learn how to use it. Most people are scared of it. AI is being used by Iron Software as a development tool to stabilize software and ensure that it is more ruggedized. So the worries, there's two worries about IP. One is, are you exposing customer data? And the answer is, why on earth would I do that? I mean, I certainly don't attach my CRM system or your business system, which I don't have access to my software. I connect it to my GitHub repository. Unless your data is in my GitHub repository, which it isn't, because it's where I keep my source code, why on earth would it be there? There are also some things like, well, if I use AI, then is the output product mine? And here's the point. Of course it is. It's like saying, if I type for the typewriter, is the copyright mine? It is a tool. It is a writing tool. It is just more advanced. It is like going from slingshots to bows and arrows to drone strikes. That is how advanced it is, but it's still along the lines of a writing tool. It doesn't replace the software engineer or their thinking or their problem-solving capacity. It just speeds up all the crap in the middle that wastes our time dealing with the computer rather than human-level concepts, which is what developers should be doing. How, if you are one of those people who's scared of AIs, here's my advice. Start paying for them. You shouldn't be using the free tier of anything. If you're probably using, if you are scared, you're probably not using API keys. You should be. Yeah? You should be on enterprise plans. You should be talking to Anthropic. You should be talking to Microsoft. You should be talking to OpenAI. You should be talking to Google. Get your account manager and ask them which plans do not train the model, A, on my data, and B, on your output based on my data, which is also, my IP. In which models is the IP mine? Ask the provider. But basically, it's just like Facebook. If you're getting it for free, you're the product. If you're paying for it, it is the product for you. That's the difference. So open your wallets, people. I spend on average $1,000 a week on API credits for artificial intelligences. It makes me 10 times faster. You've got to do the math on whether or not that's worth it for you. But by and large, if you're not paying for AI, your data is training it. And there are certain tools I do not use because I know that they train on, not on my data, but on the data that it produces for me. I don't allow that. Complete privacy. First thing is WebAssembly. Find out what it is. Most people think of it as some widget in your browser. It's not. It's a runtime, just like the .NET runtime, and it works in your browser, and it works in IoT, and it works in your phone, and it works in your desktop, and it works in your server, and it works in edge computing, and it doesn't need to be installed. It's already there. That is the powerful runtime for you to be deploying to. It's just a new deployment target. If you need to keep things really secure and run in high security environments, so there's advantages across .NET for that. You can do WASM. If you wish to make executable software or DLLs that can touch the file system, you use WASI. They're both in there in .NET 10. The next thing about this is AI encoding. What you need is a Hello World project. You don't want to be trying this on something you are, on the biggest, on a large repository and expecting magic things to happen. Vibe coding is not a thing. You don't say, hey, just tidy this up and everything will be perfect. That is not a reality. It's vibe engineering. You go in there knowing what you want, how to do it, and making sure the AI asks you questions all the time and follows your instructions. So how do you do that? You download a way of coding on your desktop so you can interact with a cloned Git repository. I recommend Claude Code by Anthropic, Google Anti-Gravity, which is just out for Gemini, and Codex for ChatGPT, which I believe you can attach an Azure billing model to, Microsoft people. All of these desktop AIs allow you to analyze a project so you can build some work.
Hello, everyone. Welcome to another episode of the webinar series targeted for the .NET 10 release organized by Iron Software. And today we would like to highlight one of the most important parts of .NET 10, which is migration, because a lot of customers, a lot of people who are using the .NET framework for a long time, they would need to upgrade their project to .NET 10 for certain purposes. And today I'd like to show you why and how we can do the migration seamlessly. And today I'm Shadman Majid. I'm with you, working in the engineering and support manager team at Iron Software. And I would like to go through all of the details on why we should migrate to .NET 10. And also I'll show you a very live working demo on how the migration would happen, what are the best practices to do it, and so on. So I think we are already aware that .NET 10 is basically the latest release of the Microsoft .NET ecosystem. Microsoft actually released this in November, and currently it's being actually very popularly used across different platforms. And actually with this .NET 10 release, it has brought in a lot of changes, a lot of improvements. And I think this is actually a good news for .NET developers because it brings in better speed and memory usage, updated C# language features, and also for cloud native applications, it has some big improvements, notable improvements. And alongside that, it also has the AI and ML tool integrations involved that actually helps to make the development faster and more seamless. So if I look into the more of the details or what's new in .NET 10, so I have broken it down into separate parts based on runtime and performance, API and language, and also cloud and deployment. So I will try to break down the benefits of like what are the changes that came in .NET 10 and why people are excited to migrate to this new version. So if we look into the reasons why the teams are now migrating to .NET 10, so I think in a nutshell, I would say .NET 10 is not just an upgrade, but it's a performance and cost transformation. And if we look into the numeric metrics, so far what we have seen is like developers around the world can be able to reach up to 30 to 50% faster API throughput. I think in different type of applications, web applications or other type of applications, you will see that since the performance improvements have been pretty drastic, so you will encounter a pretty significant API throughput or API output than before. The second thing is the cloud costing will definitely reduce because, like I said, that the container size, image size is actually reducing, and the cold start time is also reducing. So that results in less CPU, less RAM. The debug flow will definitely improve because the ahead of time compilation currently supports much more many more libraries and project types, and the image sizes are also minimal. And with the new C# 14 features, it's easier to maintain with less technical debt. And finally, you can see that it is optimized for AWS, Azure, or containers. That means like when you are doing a large scale deployment in the cloud, so in that case, you have the option to do it much more faster. So now I will move on to a live demonstration on project migration to .NET 10. So now I'll be sharing a live demo on how we can migrate a simple web application to .NET 10. And for this demonstration purpose, I am using a Blazor application that was previously in .NET 8, and now I'll be converting it or migrating it to .NET 10. So the first basic step that you need to do when you are looking to migrate your application to .NET 10 is to install Visual Studio 2026. So I think previously you had the Visual Studio 2022 installed, but the good news is with the .NET 10, the Visual Studio 2026 comes as well. And actually, if you look into the previous version of 2022, you will not get the support for .NET 10. It supports up to .NET 10, .NET 9. Sorry. So basically, you can download the Visual Studio 2026 for free, the community edition, the professional or enterprise edition, based on like your needs, and you can download it from the official website, of course. So I already have it installed. So that's why it's already there. The next thing that you need to do is to install .NET 10. So if you want to actually do that, there are actually multiple ways, but one of the things that you should actually at first check is that if you have .NET 10 installed or not. So from the CLI, you can easily check this. So in my terminal CLI, I can see that the .NET 10 is already installed, because when I installed Visual Studio 2026, then it prompted me the option to install .NET 10 as well. So basically, if you don't have .NET 10, you can also install it officially from the .NET 10 website of the Microsoft, and then you can get it installed. So basically, once all these are there, so you now have Visual Studio 2026 and also .NET 10. I just wanted to put in a small disclaimer on Visual Studio 2026. It already has a lot of advanced features. Specifically, I think you can try out the AI and agentic based coding features. That is like very helpful to reduce your development time and make things faster. So basically, if I get back, what we have done so far is we have installed Visual Studio 2026. And in the next step, what we have done is we have installed the .NET 10 framework itself. So now if I get back to the project, now what we need to do is we need to change the target framework across all of the projects and all of the class libraries inside the same solution. So if you look into my solution, it actually has 5 separate projects and class libraries. So what I'll be doing is I will be opening the CSproj file, like you can see here, and change the target framework to .NET 10, .NET 10.0 for all of the 5 projects and class libraries that I have. Okay. So now I'm done. I have changed the target framework for all of the projects and class libraries. The next thing that you need to do is to update all of the NuGet packages. It's very important here because as you might understand that NuGet packages have dependencies on each other, and there could be cases that a previous backward version is not forward compatible. That means it might not support .NET 10. So in that case, to make everything aligned, you should, as a best practice, update all of the NuGet packages. So it's very easy to do that. If you go to Tools, NuGet Package Manager, and click on Manage NuGet Packages for Solution. So in that case, you see the installed packages, and 4 of them are here that are installed, and 3 of them you can update. So you can easily update them from the updates option. And if you select all these packages, so you can update them based on what you need. So since I am actually working on project where it has 5 separate dependencies, so I'm not doing it for complexity purpose, but you can easily do that as a simplicity. And I think the libraries I'm using, Iron OCR and Iron PDF, it's basically compatible. The previous versions are also compatible for .NET 10, so that's why I'm not getting into the complexity. But as a best practice, you should always update the NuGet packages so that everything is aligned. Anyways, so now what we have done is we have installed Visual Studio 2026. Next step, we have installed .NET 10. We have updated the project target frameworks, and I have updated the NuGet packages. So now the what comes next? What is the next part that needs to be done? So since this is a web application, so for web applications, currently like for the web API interaction, so previously Microsoft supported Swagger, but in the newer versions of the .NET, so it no longer supports Swagger, rather than it's replaced with OpenAPI. So previously in this application, since I was using .NET 8, I was using Swagger. So I would need to replace Swagger with OpenAPI. And for that reason, I need to do a couple of things. So the first thing that I need to do is to install the packages related to OpenAPI and Swagger UI. So the first thing that I'll need to do is to install Microsoft.ASP.NET Core.OpenAPI, this package. Okay, and I have 5 projects, but I need to install it in the web API project because that's where the web interaction is being done. So I'll install this. Okay. Okay, so now it shows that it's installed. And another thing that I need to do is to install swashbuckle.ASP.NET Core.Swagger UI. So this is because just to show the Swagger UI interaction and Swagger UI, yes. So if I install it in the demo.web API project as well, so now I have the necessary packages installed. But the next thing that I need to do, yeah, so the next thing that I need to do is to change the configuration in program.cs, because it has some interaction or some additional things that need to be changed. So like, for example, at line 11, you can see that I had added the Swagger gen, but the Swagger gen should not work. Rather, I will have to replace it with line 12. I've commented it already, but so I'll replace it with builder.services.add OpenAPI to include OpenAPI. And another thing that I need to do is I need to replace, I'm not using Swagger, I'm replacing it with OpenAPI. So I need to remove line 28 and 29, which uses Swagger and Swagger UI. Rather, I will use it to map OpenAPI when my environment is a development environment. And also in the Swagger UI, I will need to change the endpoint path to point to the OpenAPI path that's necessary. So that enables me to do what? That enables me to actually map the project properly to OpenAPI, replacing Swagger. So now what we have done, if I once again recap, Visual Studio installed, then .NET 10 installed, then NuGet packages updated, then OpenAPI has been replaced with Swagger by installing some NuGet packages and updating the configuration in program.cs. There is one last step left that you need to do. And this is very interesting and this is very helpful as well. So you need to update the solution file. So This is a very interesting update and very useful update that got introduced with .NET 10. So I have opened up the previous solution file for .NET 8. So see, this .NET 8 solution file is very bloated because you see that it contains a lot of things, a lot of keys, a lot of configuration and stuff. So with the new release of .NET 10, it has become very, very simple. All you need to do is to create a new solution file with the extension .slnx, and once you do that, you would only need to add all the project paths inside it, and that should be fine. And just if I look into this, this is the new demo.solution.slnx file, and see, is very clean, not bloated at all, very clean. What it contains is basically the project path to all of the 5 projects and class libraries, and that's all. There's no other configurations and any other settings, very easily readable and settable. So once you set up all of these things together, now your project is ready for migration to .NET 10. That means now if I run the project, it will run properly uh, as an application, and everything will go as it is. So if I if I now choose the project demo, yeah. So the demo web API, and now if I run it, let's see how it looks like. Okay, so it's building. Yeah. So the build has been completed, and this is my console. Yeah, everything is running, and see, the Swagger has opened up. So that means everything is well in place. So this means like the application is running properly, and maybe if I want to try out something, so yeah, I tried out the weather forecast API and it responded with the code 200. That means this is working completely fine. So this is all I wanted to share regarding the demo. That means with following a pretty few simple steps, we can do the migration very easily. So let's get back into the slides. So here, I've once again just put in the steps in a nutshell for everyone's recap. So first step for migration is installing Visual Studio 2026 and .NET 10 SDK. Second step is to update the projects to .NET 10. Inside the same solution, update all projects and class libraries. The next part you need to do is update all NuGet packages and Swagger. Like I said, that Swagger is replaced with OpenAPI, so you need to install the relevant packages like showed here. And the last part is to update the solution file to .slnx extension. That actually helps to remove the bloating of the previous SLN or solution files, and everything is much more cleaner. So now let's look into some of the best practices for migration, not only for .NET 10, but if you are considering migration from any framework to any other newer framework, how you would do it, because migration is always a very big pain and a very time consuming matter if not done carefully and systematically. So I've broken it down into 4 separate steps. The first step is to prepare. So for .NET, you need to audit the current .NET versions, dependencies, and NuGet packages. It's very important to do it first because you need to realistically understand what version upgrade you can actually reach. Because when you are working on dependencies and packages, there are certain dependencies and packages that would not support the upgrade. So based on that, you can plan the upgrade path, whether you can upgrade to .NET 10 or .NET 8 or .NET 6, whatever it is from your previous version. So the first thing to do it is this, because if you don't do this step, what happens is once you upgrade, everything will break and it's very difficult to do the debugging backwards. The next part is modernizing. That means like once the upgrade is introduced, so you need to remove the legacy APIs and deprecated libraries, because with the newer version, the previous libraries won't be supported, and the legacy APIs, previous API implementations won't be supported. Like for .NET 10, I mentioned that in C# 14 is introduced, which introduces quite a few new and very helpful features for making coding easier and modernized. So you would need to look into that. Another thing is like to enable nullable reference types and refactor old async patterns, because if you look into the trend of the previous few .NET releases and also for the other framework releases, so these are the areas where the code improvement needs to be done, needs to be changed, and needs to be checked as well. The third part after preparing and actually modernizing is to introduce tests. Testing is a very important part when you are migrating, so you need to introduce unit tests and integration tests to make sure that if there is any problem happening after the migration, you can capture it during the testing phase rather than it going live to production. And you can validate the performance, memory usage, and cloud Docker deployment compatibility with the new version before actually releasing it. I can give you some examples that during the official .NET release, Microsoft actually showed a very simple console application that previously took 40 seconds to load, but right now with the new release, it's now taking just 3 seconds. So this is something that similarly for the .NET 10 release or any .NET migration, you can test out what are the improvements in performance, memory, and also in terms of the Docker image, in terms of the deployment compatibility, how it's been working. So it's very easy to do the benchmarking and everything, and I think I would recommend to do that when you are migrating. The fourth part is to do the deployment, actual deployment. So for that reason, the most common way is to use the CI/CD pipeline with different stages, of course, for like testing, for staging, and also for the final release, final production release. And definitely having the unit tests, integration tests, and automation tests running in the pipeline to make sure that nothing goes in the pipeline untested. And a very common example for large scale deployment, especially companies that have a lot of clients, a lot of servers that you are looking to do the deployment, it's better to do a phase-based rollout like NAD rollout or blue-green deployments. That means you release only 5% of the you release only to the 5% of the servers or 10% to the servers, and as you get positive results, you keep on releasing incrementally. And if the results are failing, test results are failing, or there is errors coming up, you can block the deployment and make sure that it's not an issue for all of your servers. So this is a very common practice that you should do. And finally, monitoring is a very important part. So once the migration is being done, you should monitor using application insights and OpenTelemetry just to make sure that migration did not break anything. So I think this is kind of like the holistic overview on how you can do the migration and make things easier for you as you move along. So now I just wanted to wrap up today's session with a final declaration. So at Iron Software, if you're not aware, so we are actually providing document processing software libraries for processing different type of documents like PDF, Word, OCR, Excel, PowerPoint, zip, and also print. So we call all of these libraries are part of our Iron Suite. That is a set of 10 software libraries available as NuGet packages and installable inside your .NET application. So I'm very happy to share that the Iron Suite libraries work seamlessly with the .NET framework. We actually are compatible from .NET 5 to .NET 10, so all of the versions are supported. So any of our existing customers who might be watching this content, it's a good news that if you update to .NET 10, it will also support all of the existing libraries. And anyone new who might be interested in Iron Software, I'm happy to share that we support this migration. And at the Iron Suite libraries, we actually made a lot of performance improvements regarding parallel rendering, caching, batch jobs for processing documents at scale. And I think that would go very well hand in hand with the .NET 10 release because it also has a lot of performance optimization included inside. And finally, through our Iron Suite libraries, we do have a 24/5 world-class global engineering support. So if you are interested to try out any of our products after the .NET 10 migration, you can test it out and reach out to our engineering support team for any help. And if you would also like to move on with the licensing, we also have flexible licensing options to get you moving forward. So yeah, that's all from my side regarding today. It was great to discuss on the migration practices, live migration demonstration, and I think based on my experience working with many customers, I've been helping through Iron Software for their deployment issues, for their performance issues. I think it will be a relief that once you migrate to .NET 10, you will definitely get a lot of benefits. So I would definitely suggest to try it out and see if this makes sense for your company. And at any point of time, I think this webinar would serve as a helpful reference to get you started and moving forward. So thank you so much for taking the time in watching today's webinar. And I look forward to catching up with all of you again in some other day. Till then, have a nice time and good day. Thank you.
Hi everyone, welcome to my webinar. I'm going to be talking about .NET 10 and the potential returns on investment that can be made by upgrading. My name is Jim. I'm one of the sales engineers at Iron Software, and I'm going to talk us through some of a small section of the improvements that have been made to .NET 10. In this webinar, I'm going to be focusing on the performance improvements in general. And I'm also going to deep dive into some specific performance improvements that have been made, as well as performing some of my own benchmarkings to compare against Microsoft's reported benchmarkings. So the overview of the improvements is no one silver bullet. It's a collection of hundreds of fairly significant performance improvements that have been made that on an application level combine to make an application very, very much more performant. We've seen the just-in-time compiler get smarter and can now see through interfaces and abstractions, can inline more methods, and it can eliminate redundant safety checks. The memory management has improved. Objects that don't escape the method can be stack allocated instead of heap allocated, eliminating garbage collection overhead. And something that I'm going to be deep diving into a little bit today is link queries and collections. Seen improvements, pretty good improvements. Some operations reportedly 50% faster. And the key insight to these improvements compound. So not one improvement itself is going to change your application a great deal, but the hundreds of improvements that have made over together can compound to make a much faster application for yourself, a much faster project. So the thing I'm going to be focusing on is collection performance, and this is why it matters. These are the processes that happen thousands and hundreds of thousands of times in your application. processing documents, for example, you're iterating through pages, iterating through words and characters each time. So reducing the overhead of these can be quite significant to an application's performance. Collections typically had a little bit of a performance tax in .NET and C# because they required an interface to extract the data. So you'd have an array, and then you'd have an interface which the program interacted with directly. The compiler's got a little bit smarter, so it no longer needs to interact with this interface and access the data layer directly. This is pretty significant, and in theory, it reduces the performance, increases the performance by 50%, as you are having half the number of interactions to access the data. In the real world, you probably won't see quite as good as that, as we will see in our performance benchmarkings, but you'll see some very good improvements. So now I'm going to switch to a demo, just to show you the benchmarking that I've done myself, and we can see what results we get. So this is the code that I have for it. It's not supposed to be a real-world scenario. It's just supposed to replicate a real-world scenario. So this won't give you particularly useful results. However, it will show you the sort of functions that you would do in any sort of document processing application. To start with, we access a PDF that I have saved, and we extract each page individually and then store them in an array. Then we split each page into words. So you have these two objects about words per page and pages themselves. We're going to analyze the middle pages using this method and this benchmark, just skipping some pages and then taking the next pages, nothing too complicated. Finding the busiest pages, and this is just a case of counting the number of words per page and finding the maximum. Similar but different, we're going to be counting the number of characters in the page themselves to find the longest page. Then we're going to enumerate all the pages using this method, just as to highlight the benefits of enumeration and this performance benefits that have been made. So I'm going to switch to the results now, as I did actually run this before. It takes approximately 30 minutes to run, so I didn't want to do it live for everyone's benefit. And the results can be seen in this ratio column, or the most easy to read results. And this can show up to 26% improvement, 27% improvement, as well as a 6% improvement as well. So not quite as high as that, but still a valuable improvement made. So what it works, and you don't need to know how this works to implement it. As I said, there's no coding changes required, but it is helpful to understand a little bit. The way my particular example is working is the link operators are, instead of using the interface of list I to access the array, it is accessing the array more directly. This is called array devirtualization. And in theory, it can deliver 50% savings on your code running. My example was a little bit less because it's a real world example, but the maximum, because they are halving the number of interactions being made, could be 50% faster. So the upside is very, very large. So there's also what else is there to explore. As I alluded to earlier, I've just done a deep dive on one very small part, and there's been hundreds of improvements. So this very small part might not affect you, but all these changes will compound to make an application level change of performance, which has a really, really important contribution to your bottom line, reducing performance overheads. Stack allocation is one thing that has shown the most improvement. Some benchmarks have shown 68% improvement, and that can be seen in the Microsoft blog, which I'll link at the end of this slide. Objects that don't leave the method can now be allocated in the stack instead of the heap, and this removes the garbage collection overhead. Inlining improvements, methods containing a try finally block can now be inlined, which is previously blocked. This unlocks tons of optimization opportunities. And there's fewer cases where the garbage collector needs to track references and writes, which is another one of the garbage collector's improvements. As I said, there's hundreds more, and I recommend you read about this on Steel and Tube's blog. He does benchmarking similar to what I've done on every single one of these improvements, and there's hundreds of examples. Really recommend reading through. As I said earlier, you don't need to understand everything, but it can be a little bit helpful. In summary, .NET 10 is just hundreds of compounding performance wins across the runtime. It's a bit of a no-brainer in terms of implementation because the efficiency improvements are huge if they affect you in the right way, and the coding changes are virtually nil. The real business impact is lower cost, higher throughput on the same infrastructure. IMPDF and .NET 10 are a powerful combination of document processing. And up next, I'd recommend downloading .NET 10 and benchmark your workloads and implement if it's right.